So today is all about trig identities. And on the first page here in the slides, which I'm not really going to spend any time on, you'll notice that there are a few main kinds of trig identities. One of these main kinds are what they call the reciprocal identities. That's the stuff in this yellow box. The second kind, those are ones where it's 1 over something. We've talked about those. The second kind are called the quotient identities. Those are the tangent and the cotangent. And then the last important group, I guess, in my opinion at least, are what we call the Pythagorean identities. And these are ones where you see squared stuff going on. Like a squared plus b squared equals c squared kind of thing. Comes from a right triangle in the unit circle. And we've talked about those as well. The most famous one, of course, being the sine squared plus the cosine squared equals 1. Because that's like the right triangle in our unit circle. And all the other ones come from some derivation of that red highlight. And we talked about that as well in our class. The cofunction identities are somewhat important. However, we don't really spend a ton of time talking about, that's not what I wanted to do, sorry, about this, because it's more of a shift of functions. So we talked about how the sine and the cosine are out of phase by pi over 2. Or in other words, if you draw the sine function and you watch 1 period over 2 pi, and you look at the cosine, if you slid it over pi over 2, it would become the same look as the cosine. That's what it meant. So these cofunction identities are basically saying the same exact thing. They're saying if you take the one function, slide it over pi over 2, you see the other one. So take the cosine function, slide it over pi over 2, you see the sine, or vice versa. That's what they're saying. So this gray stuff we kind of know mentally, but we don't really do a lot with algebraically. And then the last one, they talk about the even and odd functions. Even and odd means what does it look like when you graph it, and does it have any symmetry kind of thing. And so the ones that are odd are the ones that you see the opposites on the outside. So the tangent and the sine are odd functions. And then if you put in the opposite of something and you get back the same thing you started with, that's an even function. So cosine is even. So down below here, if you're looking at the cosine, that's the even one. And if you're looking at tangent and sine, those are the odd ones. Okay, just a reminder. Again, we're not going to be doing a ton with this, but just for your information. Now, one of the nice things about math is it's often very helpful if when you're looking at the math thing, you see keywords that tell you what to do. For example, I noticed that they tell us something about the secant, but I'm not really good with secant, so when I think about this, in my mind, the first thing that popped into my head is, instead of writing down secant, I'm going to write down cosine, because the cosine is the reciprocal of secant, which means that my cosine is negative 2/3, because I flipped the fraction upside down. They're reciprocals of each other. And then I also noticed that they talk about this tangent thing. So they're mentioning two different functions with numbers, and they asked me to find all 6 values. We've actually done this before. This is where, when you see these things, you draw a triangle. So I noticed that my cosine is negative. Cosine is negative in the second and third quadrants. And then they also talk about the tangent. So here they talk about the tangent being greater than 0, which means it has to be
third quadrant.
Positive. So that's in the first and the third quadrants. So the cosine is true in 2 and 3. The tangent is true in 1 and 3. The only place where they're both true is quadrant 3. So that's where I draw my triangle. So I go to quadrant 3, and I draw my triangle. Remember, you always have to be going to the x-axis. The angle always has to be next to the origin. And if the cosine is 2 over 3, that means adjacent over hypotenuse. So the adjacent is the x part, and the hypotenuse is the bottom part of that fraction for the cosine. And the hypotenuses on your triangle will never be negative, so that means, of course, that the 2 is negative. Using the Pythagorean theorem, I have 3 squared, which is 9, minus 2 squared, which is 4, so that's a total of 5. Take the square root. So this is going to be the square root of 5, and since it's below the x-axis, don't forget about the negative. It's negative radical 5. And now if I want to write down the trig functions, I just start listing them all out. So we did before, if you remember, sine. The sine is the opposite over the hypotenuse, so that's negative root 5 all over 3. We have the cosine, which I wrote as we switched the secant around. Gannon?
What if we the square root of 13?
No, because you subtract from the hypotenuse. We already have the hypotenuse. You add when you're looking for the hypotenuse. So you have a squared plus b squared equals c squared. This is already the c that you're going to be squaring. The cosine was the negative 2/3. And then the tangent of the angle is the opposite over the adjacent. So you have negative root 5 over negative 2, which is the same as root 5 over 2. And these are 3 of the functions, and then all you have to do is flip them to get the cofunctions. So cosecant they actually gave us. That was the beginning part of the problem. Oh no, it wasn't. Pardon me. So I flipped that. I was thinking of secant. Sorry about that. So this is negative 3 over root 5, and you would simplify, of course. I'm not going to simplify it right now. No space. The secant, correction on my part, is what they gave us. That was negative 3 over 2, flipping the fraction, of course. And then the cotangent of the angle, flip the tangent, and I get 2 over root 5. And of course, these root 5s we would bring up to the numerator and then take the root off the bottom. So like, for example, the cotangent would instead be 2 times the square root of 5 over 5. And on a test, that's what you should do. But here for now, I'm just going to leave it like this. Questions about number 1? Okay, so when I am solving math problems, I'm always looking for patterns, because math is the study of patterns. And the first thing that I notice in number 2 is that there are 2 things that say sine. Do you guys notice that? Okay, so I'm going to notice that I see sine here and sine here. And so this is what I'm going to do. I'm going to take that sine of x, x representing the angle, and left over, if I factor that out, I would see in the first part a cosine squared of x, because sine times cosine squared is what you see in the first part. But what would come second? Minus 1. Because sine times minus 1 is the negative sign I see on the end. I want you to look on that first slide, and what I want you to notice is this. Do you see the thing that says sine squared x plus cosine squared x equals 1? Do you guys see that? Okay?
Yeah.
All right. Do you see this? If I move the pink thing, the sine squared, to the right-hand side, it becomes negative sine squared x. With me?
Yeah.
Then, if I move the 1 to the left-hand side, it becomes negative 1. And I still have my cosine squared of x. Don't blink. Son of a gun. Do you see it? Here, let me help you. the cosine squared of x minus 1 is negative sine squared x. Which means that when I simplify, I get negative sine cubed. One strategy you might be using today is you might factor. Strategy number 1. It's a possibility. In number 3, what I notice is there are no squares at all anywhere. Everything's sines, cosines, cotangents, something like that. Whenever I see no squares, nothing that's being squared, I think